Alright, so for number 5, they want you to write it first as a ratio of common logs, and for B as a ratio of natural logs. So log base 5 of x becomes log of x over log of 5. Remember, when there's no base, that means it's a common log base 10. And for part B, natural log, it's just ln x over ln 5. So number 10, same thing as number 5. They just want you to write it as a ratio of common logs and a ratio of natural logs. So for A, it's log of 4/5 over log of A, and for B, it's natural log of 4/5 over natural log of A, and that's it. Alright, so for number 20, they want you to evaluate log base 20 of 175, and so I wrote it both ways, just to remind you that you have a choice. As long as you don't mix them up. So for example, if you put log, you have to put log in the denominator. Don't mix them up like this, where you have log up here and natural log down here, or vice versa. So plug that into the calculator and you get 1.724, because they want you to round it to three decimal places, so right here. Now remember what this means. This means that what we found right now is 20 to some power equals 175. So what we found was that 20 to the 1.724 power is going to give us a number close to 175. Okay, it's not going to be exact, it's just going to be very close. So for 25, they want you to use log base B of 2, of 3, or of 5, right, to evaluate this log. So I'm going to rewrite log base B of 8 as log base B of 2 cubed. So then I know that this 3 right here is going to become the coefficient of the log. So this is going to give you 3 log base B of 2. Well, they gave you log base B of 2 to equal log base B of 2, 3562. And so now you just have to do is punch it into your calculator. So after you multiply, you get 1.0686. Alright, for 35, I know the instructions say to graph it a different way by using change of base, and we'll do that in class probably tomorrow. But for now, I'm just going to use transformations. So notice how I rewrote the equation. Instead of x over 2, I just put it as 1/2 x, which is the same thing. But I think having it like this, you may be able to identify the b a little bit easier if it's like this versus this way. So here this tells me that there's going to be a horizontal stretch by a factor of 2, and so that's why you see the 2x over here. Okay, so here are the reference points, and that's the only parameter that we have, the b, that will change the function. So 2 times 1 is 2, 0, and then 5 times 2 is 10, and then 1. So we're going to graph. So the let's see, this is a log function, so it's going to have h is 0, so the vertical asymptote is on x equals 0. And then I have 2, 0 as a point, and then 10, 1. And so it goes like this. Okay? Alright, so for number 40, it's asking you to use the properties of logarithms and simplify the expression. So the first thing I'm going to do is I notice that I have the log of a product, right? So I'm going to separate this as a sum of 2 logs. So this becomes log base 3 of 9 squared plus log base 3 of 2 to the 4th. So now log the first one, this term right here, I can move the 2 over. I could also change the 9 to 3 squared. So this becomes log base 3 of 3 squared plus log base 3 of 2 to the 4th. So this squared right here becomes a 4. So now I have 4 log base 3 of 3. And then this 4 right here goes to the front, so 4 log base 3 of 2. So remember, this equals 1. So this is 4 times 1, which is 4, plus 4 log base 3 of 2. And so this is the exact value. They're not asking you to use a calculator and get an approximate value, just to use the properties and simplify. Okay, so this is as much as we can do, okay, without using a calculator. For 50, the next few problems we're going to be expanding. So that means use the properties of logs to expand. So here I have the log of a quotient. And again, in this book, they keep writing the base 10 when it's a base 10, when it's a common log. All other books that we've used in the past don't do that. So that's why I usually don't do that. So if you don't see me writing a base 10, that's because it's a common log. Okay? So the log of a quotient is log 7 minus log z. And that's as much as we can do. So here we have another log of a product. Okay, so the log of a product is equal to the sum of the logs. So we're just going to take natural log of x plus natural log of y plus natural log of z. And that's the expanded form. Okay, and for this one we're going to condense. So our answer is going to have a single log. So this is the log, or the sum of two logs. So this becomes the log of a product. So natural log of y z. And that's it for this one. Alright, so here I have a combination of sum and difference of logs. So I know that, oh, and then I have coefficients. So I know that this 3, this 2, and this 4 are actually going to go and become exponents of each of their individual logs. So that's the first thing I'm going to do. So let me go ahead and write that down. So this becomes natural log of x to the third plus natural log of y squared minus natural log of z to the fourth. And then here I have the sum of two logs. So when I combine this, I get the log of a product. So natural log of x cubed times y squared. And then right after that I have the difference, right here, the difference. So that means it's going to be a quotient. So z to the fourth. And so here's the answer right here. Alright, with 95, they want you to find the exact value and without using a calculator. So here I have the difference of two logs. And so this becomes the log of the quotient. So 375 over 3. And so this is, when I simplify this, I get log base 5 of 120, what is it, 5? Okay, so remember what this means. This means 5 to what power gives me 125. So whenever you're finding the value of a log, you're actually looking for the value of the exponent. The exponent of the base, that would give you this as an answer. Okay, so then this is going to be, oops, 3. Because 5 to the third is 125. So the answer to this log is 3. Okay, for 100, this exponent right here is going to become the coefficient, but there's already a 3 there. So when you bring this 5 over, it's going to be 5 times 3 natural log of e. So that's going to give you 15. Now natural log of e is 1. So the answer here is 15.